Good morning, everybody. Today we are going to go over what happens with the Pythagorean theorem if we don't know which one of the legs are versus not knowing the hypotenuse. So we've learned how to solve for the hypotenuse, but how do we use Pythagorean theorem to find one of the legs? So reminder that those legs are the two sides that create the right angle because the Pythagorean theorem only works for right angle triangles. So I'm wanting to solve for A in this situation. So right now my Pythagorean theorem is set up to solve for C. So I want to get this A squared alone on the side of the equal sign because I want to know what that equals. So I need to get this B squared and move it to the other side of the equal sign. I do that by subtracting out b squared, because right now I have plus b squared. If I subtract 1, that equals 0 and they cancel. But whatever you do to one side, you got to do to the other. Okay, so we're going to put b squared, we're going to subtract that from c squared. So our new equation to be able to plug into would be a squared equals c squared minus b squared. Okay, so we're going to arrange Pythagorean theorem if needed. So sometimes you may be solving for C and you don't need to change it. So our second step would be to plug in. Okay, so we're going to plug in the values that we know. So A we do not know, so we're going to bring that down. C is 8. So we're going to replace C with 8, leave that squared. Okay, then I'm going to subtract b, which b is 5, so subtract 5 squared. Okay, our third step is that we're going to do the exponents. Okay, so this is just like orders of operation. P is parentheses. I don't have parentheses, so my next would be the E in PEMDAS, and that is exponents. So we're going to solve the exponents. So we don't know A yet. 8 squared is 64. And then subtract 5 squared, which is 25. Okay, so your fourth step is to either add or subtract, again, depending on which type of Pythagorean theorem. If you're using just the regular a squared plus b squared equals c squared, you would do the addition. In this case, we're doing subtraction. So 64 minus 25 is 39. Okay, and then your last would be to take the square root. Okay, because we don't want a squared. Right now, that is a times a. We just want a. So if we take the square root, remember, we got to do it to both sides. A would equal the square root of 39, or in a decimal form, A would equal 6.24, and I just did that on my calculator. Okay, so A would equal 6.24 in this situation, which matches up with the fact that C has to be the longest line. So it's bigger than B, and now we know A, and it's also, so we know that we're on the right track. And guys, it would be the same as if you were solving, let's say we knew what A was and we were solving for B. Again, just rearrange the Pythagorean theorem. So we want to solve for B. So this needs to be on the, it needs to be alone on the side of the equal sign. So we want to move the a squared. So we would subtract a squared, subtract a squared. So those would cancel out, and I'd be left with c squared minus a squared. So it doesn't matter whether it's a or b, you're still subtracting that one side from the hypotenuse.